Our next learning target is rate of change. Rate of change is a very important concept that we understand, and what it does is it shows the relationship between two values. A rate of change that you are most likely familiar with is miles per hour. So as your miles change, the hours change as well. So it shows the relationship or how those two rates change together. Our essential question today is how to interpret rate of change, which is the most important part of it. Calculating rate of change is one thing, but understanding what the rate of change means is really the most important part. So first we'll practice calculating and then we'll interpret what it means. Rate of change is change in the y value or the output over the change in the x value or the input. When you're looking at the steps off to the side, this triangle means change. So this means change in y over change in x. That ratio gives us our rate of change. So let's try that with our table here, hockey team's offense. Remember, anytime you're given a table, the x value or the input or the domain piece comes first, the y or the f of x or the output or the range comes second. So when we're calculating our change in y, how did the y value go from 2 to 4? Well, the change is a positive 2. How did our x value go from 1 to 2? Our change was a plus 1. So our first ratio, change in y over change in x, is 2 over 1. In order to determine if the rate of change is constant, we have to check the rate of change for the next set of ordered pairs. So the change from 4 to 6 was a plus 2, and the change from 2 to 3 was a plus 1. Those are the exact same values, so we do have a constant rate of change. And the last piece is to interpret what it means. Step 4 is the interpretation part. It says use the labels on your ratio to interpret the rate of change. The change in y, the y value represented goals, and the x value represented games. So our rate of change was 2 goals per game, an increase of 2 goals per game. Your rate of change can also be negative. Let's try that again. This time we're calculating miles per gallon for our vehicle. So what is the change in miles? Well, to get from 25 to 80, you added 55 miles. The change in our domain, or our x, or our input, is gallons. We added 2 gallons. So our first change in y over change in x is 55 miles per 2 gallons. So taking a look at our next rate of change, to go from 80 to 140, we added 60 miles. And to go from 3 to 5 gallons, we added 2. So our next ratio is 60 over 2, which of course is not equal to 55 over 2. So we don't even need to check the last ratio. We already know that it is not constant, but we can still interpret it. There are a lot of things that would make it inconsistent. For example, weather affects it. You get worse gas mileage in the winter than you do in the summer. How fast you drive affects it. The faster you drive, the worse mileage you get, etc. So, as we were already talking about, the change in y was miles, and the change in x was gallons. So each ratio would represent miles per gallon. Next, we're going to take a look at a couple of word problems that also help us set up a rate of change. So the first thing we need to do is figure out the x and the y values, what's the input and what's the output, and then we can determine the rate of change for each set of values. All right, so Jessica weighs 87 pounds currently, and she wants to gain weight. After 5 weeks, she weighs 97 pounds. What is her average rate of change? This one's a little tricky. The second rate of change does give us an input and an output, but the first one doesn't appear to. So let's start with the easier piece of information, and then we'll go back to the first one and see if we can't figure out what both values are. So after 5 weeks, the input is the 5 weeks because the 97 pounds can't change until time changes. So our first ordered pair is 597. So thinking about that, after how many weeks, that's our input, did Jessica weigh 87 pounds? And the answer is 0 because it's her current weight. And 5 weeks later, so adding 5 to the 0 weeks currently, gave us the 97 pounds. So we can calculate the slope from a set of ordered pairs as well. We're still setting up change in y over change in x. Change in output, the output was her weight, over change in input, and the input was the time. So we can think about how did her weight change. She started at 87 pounds and went up to 97 pounds. So that was an increase of 10 pounds. How did the time change? She started at 0 weeks and went up to 5 weeks. So our rate of change, when we put that in simplest form, is 2. What did the y value represent? Pounds. What did the x value represent? Weeks. So she had a rate of change of 2 pounds per week. Finally, we're taking a look at one more example. Andrew had 6 gallons of milk and was making milkshakes. After 2 hours, he had 2 gallons left. So again, this is a similar one to the last one, where the second piece of information gives us the input and the output. The input was the 2 hours, and the output was the 2 gallons. So now let's take a look at that first one. The input was currently, after 0 hours, he had 6 gallons. Setting up our ratio change in y over change in x gives us our rate of change. This time thinking about it, he started with 6 gallons and went down to 2 gallons. So the rate of change was a negative 4 gallons, but the time went up 2 hours. So this time our rate of change was negative 2 gallons per hour. Here are a couple of U-tries for you, one determining the rate of change from a table, and the second one taking a look at a word problem.